Welcome back to MadLad Labs. This is a model altimeter that I was working on some time ago for use with a flight sim. It's a standard 3-needle altimeter with 100, 1,000, and 10,000 foot needles and a pressure setting knob. It's 3D printed, and I quite like how smooth the gears mesh together thanks to the SLA printed gears. The needles are 3D printed and hand painted, while the dial face is a sticker that I designed for this project. I got pulled away from this project before I could finish it, so I never got around to adding the electronics. Recently, a commenter requested that I demonstrate how the gearing works, so here we are. Unfortunately, I don't have the original CAD files for this, but we can still look at the device itself, plus some pictures and diagrams to help explain things. First, let's take a look at the device from the side and identify the different components. This will be a little bit dry, but hopefully with the visuals it won't be too bad, so let's get into it. The input gear is a compound gear with 20 and 10 tooth sections, and it would be driven by a small stepper motor. The 20-tooth section of the input gear drives the 100-foot needle gear, which has 10 teeth, resulting in a 1 to 2 speed increase. The 10-tooth section of the input gear drives the 1,000-foot needle gear, which has 50 teeth, resulting in a 5 to 1 reduction ratio. The 1,000-foot gear is compound and also has a 10-tooth section, which drives a 20-tooth section of an intermediate compound gear, which is the same as the input gear but free spinning. The intermediate compound gear also has a 10-tooth section, which drives the 10,000-foot needle gear, which has 50 teeth, resulting in another 5 to 1 reduction ratio. This gearing results in a 10 to 1 reduction ratio between each progressive needle. And in case you're curious, the reason why the input isn't going directly to the 100-foot needle is because my original intent was to have a magnetic encoder mounted on the 100-foot needle for calibration and zeroing, but unfortunately, like I said before, I never got around to it. Finally, let's take a quick look at the printed gears. The output consists of 3 gears. The 100-foot needle has a gear that's glued to a 3D printed shaft so that it can be supported by a bearing. The 1,000-foot needle gear is this compound gear, and the 10,000-foot needle gear is just a simple gear with 50 teeth on it. All the output gears have bores to accept brass coaxial rods and tubes that couple to the needles. The input and intermediate gears are the same gear part, but the input gear is glued to a 3D printed shaft so that it can be supported by a bearing and to accept the motor shaft. Finally, we have the pressure setting knob, which drives a small gear that meshes with a large diameter gear that has the pressure adjustment scale on it, which is also a sticker. The pressure scale gear is compound and has a smaller diameter section that meshes with a gear with a long shaft that allows measuring the rotation if a magnetic encoder is added, or setting the rotation if you couple it to a stepper motor. This pretty much covers the gearing and the printed parts of the altimeter. If you have any questions or comments, please leave them below. And if you want to see more projects like this, please subscribe to the channel. And if you're feeling particularly generous, consider supporting the channel via the Ko-fi link in the description. Thanks for watching, and I'll see you in the next video.